Epicon tutorial.
Good day, students. Today we want to solve a boundary value problem by differential transform method. In our previous videos, we have considered a solution of an initial value problem. But today now, let's see how we can apply differential transform method to solve a boundary value problem. So as usual in our previous videos, we have to transform each of the terms of the differential equation. So we are familiar with the second order is transformed as k plus 1, k plus 2, y k plus 2. Then we have y prime there, the first order derivative, k plus 1, y k plus 1. We have suppose we have a constant a there. This will be transformed as a dot chronicle delta into k comma 0, which is equal to, it will be equal to a if k is equal to 0. If k is equal to 0, or it will be equal to 0 if k is greater or equal to 1. So that's how we compute a constant, or how we transform a constant in differential transform method. Then for an exponential, suppose we have an exponential b raised to power a raised to power bx. This is transformed as b raised to power k over k factorial. B is a constant, so b is a constant term. B is a constant term. Then we have to transform the boundary conditions too. So from the equation, our boundary conditions is y of 0 equal to 0 and y of 1 equal to 1. So we transform it. So we are aware, so we can check our previous videos to learn how to do that. But y of 0 equal to 0 is transformed as y of 0 here equal to 0, and then y of 1 equal to 1 is transformed as y of 1. We represent it by a capital letter A. So now, going by our transform functions here, so we're going to substitute these functions into the differential equation here. So substituting that into the differential equation, we are going to have k plus 1, k plus 2, y k plus 2, plus k plus 1 y, okay, let's see, k plus 1, y, k plus 1 minus our chronicle delta k, comma 0. So since our constant is 1, so 1 we multiply in the chronicle delta, then equal to, and here for our exponential, b is 1. So we're going to be having 1 over k factorial. 1 over k factorial. 1 over k factorial. So then from here now, we can, let's make y into k plus 2 the subject of the expression or the equation. So we're going to have k plus 1 into k plus 2. Then this will be negative 5 into k plus 1, y into k plus 1 plus chronicle delta k, comma 0 plus 1 over k factorial, all brackets. So from here now, we'll be solving this equation when k is 0, k is 1, k is 2, and so on and so forth. So when k is equal to 0, when k is 0, we have a y of 2 equal to 1 over 1 times 2 into negative 5 times 1 times y of 1 plus chronicle delta 0, comma 0. So the values of k is the same, is equal to 0. So plus 1 over 0 factorial, 1 over 0 factorial. So simplifying this, we are going to have 1 over 2 into 5 times our y of 1 is a, so it's going to be a plus conical delta 0, 0, that will be 1, then plus 1 over 0 factorial, that is 1. So when we now compute this one, if we simplify this, y of 2 will give us half 1 over 2 into 5a plus 2, which gives 1 over 2 into 2 minus 5a. So that's our y of 2. So let's quickly go for 2 more terms. When k is 1, when k is 1, so we'll have y of 3 equals 1 over 2 times 3 into negative 5 times 2 times y of 2 plus chronicle delta 1, 0 plus 1 over 1 factorial. So this gives 1 over 6 into negative 10 times our y of 2. We have obtained that just here. So that's going to be 1 over 2 into 2 minus 5a plus, this will be 0 when k is greater or equal to 1 plus 1 here. So simplifying this, if we simplify this, our y of 3 is going to give us 25a over 6 minus 3 over 2. So that's what we obtain for that. So finally, let's quickly check, look for one more term. When k is 2. When k is 2, that will be y of 4 equal to 1 over 3 times 4, brackets open, 5 times 3 times y of 3 plus chronicle delta chronicle delta 2, 0, chronicle delta 2, 0 plus 1 over 2 factorial. So this gives us 1 over 12 into 15 multiplying our y of 3 here is 25 25a over 6 minus 3 over 2. This will be 0. K is greater or equal to is greater than 0 plus 1 over 2. So if we simplify this expression, this will yield y of 4 becomes negative 125a over 24 plus 46 over 24, which simplifies as 125a over 24 plus 23 over 12. 23 over 12. So bringing all the terms together, so we write it as this: y of x equals to y of 0 plus y1 x plus y2 x squared plus y3 x cubed plus y4 x raised to power 4. So substituting the values, So this y of 0 is 0 from the initial conditions. Then y of 1 is a from the condition 2. Then plus y of 2. We obtained y of 2 as this can be simplified as 5a over 2 into x squared plus 25a over 6 minus 3 over 2 x raised to power 3, and so on like that. So the next thing we want to do is that how do we obtain the value of a? To obtain the value of a, we are going to apply this condition, y of 1 equal to 1. This means that at x equal to 1, y is equal to 1. So from that we say when we introduce that, we are going to have a plus 1 minus 5a over 2 plus 25a over 6 minus 3 over 2. So if we simplify this, simplifying this will yield 16a. It will yield 16a over 6 equals to 3 over 2, which gives our a as 9 over 16. Our a is 9 over 16. So we will now go back to this our equation in terms of a, the one we obtained in terms of a, and substitute. When we make substitution, our y of x now becomes a into 9 over 16x plus 1 minus 5 over 2 into 9 over 16 x squared, and then plus 25a, 25, let's substitute for our a, so 25 over 6 into 9 over 16 minus minus 3 over 2 x cubed. So simplifying that will give us the series solution for the differential equation. So what we have learned today is how to solve a boundary value problem by differential transform technique. So we started by transforming each of the terms in the boundary value problem and then substituting the values here. After that, we started solving by equating k to 0, k to 1, 2, and so on and so forth. So the more terms we obtain, the better our series solution, or the closer it will converge to the exact solution. So, and that's why it is necessary to obtain more terms as we are doing the solution of the differential equation. So it's necessary we obtain more terms. Thank you.